Okay, here's problem number 46. We didn't cover this specifically in class, but here's the idea. The idea is that in computer science, there's something called big O time, and it relates to how efficiently an algorithm is executed as the size of the data set that it's sorting enlarges. Okay, the most popular, easy to write sort of a set of data is called a bubble sort. But there are other sorts. One of them is referred to as a binary tree sort. Okay?
There's all sorts of sorts.
There's all sorts of sorts. The quick sort, the merge sort, there's all sorts of sorts. You judge the sorts by something called the big O time, the operational time. Okay? The bubble sort has a big O time of n squared. Meaning, if your data set doubles, it takes 4 times as long to do the sort. The most efficient sort, the binary tree sort, has an operational time of n natural log n. Right? So the question is, I've got two sorts, or I'm searching through something that's taking a bunch of time. Which of these searches should I use? The one that has an operational time of n log base 2n, or should I use the one that is n to the 3 halves?
Top one.
Limit as n approaches infinity.
We set the limit.
Well, what we're going to do is we're really asking which one grows faster. The one that grows faster is the one that you should avoid.
Yeah.
The one that grows more slowly
What do you want?
is the one that you want, because even as the data set gets much, much larger, it doesn't take as long to find things. Okay? So indeed, what we're going to do is we're going to take the limit of this as
Can you
n
do n?
approaches infinity, sure. Right? And we'll go ahead and say, what do we have? Well, as n goes to infinity, both of those go to infinity.
It's L'Hopital.
Okay, well, before you L'Hopital it,
I'm done.
what I think we should do, I think we should clean it up. Do you agree with that cleanup? All right. Now when I L'Hopital, it's still infinity over infinity? Yeah? All right. So let's what? Does the square root of n go to infinity as n goes to infinity?
Well, I'm just thinking if we L'Hopital it and keep L'Hopitaling it, would it make a circle like we've had a few times in class?
Well, I think when we take the derivative of this, we end up getting 1 over n. And I think there's an additional multiplier of natural log 2. I think that's the derivative of. Would you check your memorize this quiz sheet?
1 over
Yeah,
n
that would
natural
be
log
it.
a.
That would be it.
Yeah. So it's the reciprocal of what you're taking the log of, and then there's an additional natural log base multiplier.
Yeah.
And so when I take the derivative of this, I'm going to get 1/2 n to the negative 1/2. And I would take the limit of this as n approaches infinity. You know what? I would like to clean this up a little bit. I would like to clean this up by really thinking of this as n to the negative 1, natural log 2. This 1/2, I'm going to take that 2 up there. And this n to the negative 1/2, I can take this up there and make it an n to the 1/2. And what do I end up with? I end up with a 2 natural log 2 on top, and on the bottom I end up with a n to the 1/2. Would you check my algebra there? I've got 2 exponents. This one's negative and it's bigger, so it's going to be on the bottom. Yeah, I think I got that right. So what happens when I apply the limit of this?
It approaches 0.
Zero.
Approaches 0. So if it approaches 0, that means this one's growing faster. This one's growing slower, and so that's the algorithm that I want. It's true. Right? So I didn't tell you about the search, the relation relationship of these ideas to search. Sorry. By the way, this is really important in terms of computer science. Really, really important. Vicky will be finding out about this pretty soon.
Yeah, Vicky.